Okay, I'd like to do another chunk of investigation. And I want to start out with that investigation of Prolog by taking a look at the example file that contains all this family information. So you see how we have all of these parents, Albert, Sally, Jane, Bob, John, et cetera, et cetera. Well, I'd like you to take the information that's in this file right here. You can pause it if you want to just look at it and tell me, see if you can create a family tree. So that's the thing that you should do next, all right? So hit pause, create the family tree, and then come back. Okay, so the family tree should look something like this. We've got Esther and Mick, and they have a child named Ruth. Ruth and Jim have a child named Mary. Jean and Joe have a child named Al. Mary and Al together have a child named Sally. Anne and Mike together have a child named Bob. And together, Bob and Sally have two children, Jane and John. Okay, so that's our family tree. This is really useful to have in your notes for what we're about to do next. In fact, you take a picture of it, write it in your notes, whatever, but what we're about to do is not going to make a lot of sense unless you have this family tree. So what I would like to do next is I'd like to write a new rule for grandparent. All right, so what would the rule for grandparent be? I'm going to write it right up here. Grandparent. So G, the grandparent, is the parent of some grandparent of some child C if the following things are true. All right, so what would those be? We'll take a moment to think about it. So we're going to have this relationship between a grandparent G and a child C. So what antecedents would we list here? Well, let's create a parent, and we're going to say we're going to have some parent P, which is a parent of our child. All right, that's not the grandparent, that's the parent. So we have some parent P, which is parent of the child, and we're going to have another parent relationship where G is the parent of P. So when you put that together, you now have a grandparent rule. So let's take a look at how this grandparent rule would get executed if we tried to examine a query that went on grandparent. I'm getting my notes so I make sure I get this right. Let's see, where is this here? Okay, cool. All right, so it's really important for this to make sense that you have these notes right here so you can see what's going on, and then we'll do a trace on the next page. Okay, well, I'll try to jump back and forth so that makes some sense. All right, so let's say we do this query. I'm just going to use G because it's going to get tiresome to write grandparents. But let's say we do G of Jane. Okay, so we're asking the question, who are the grandparents of Jane? All right, well, let's take a look and see if we can figure out what the answer is going to be. So Jane here is at the bottom of our family tree, and it looks like Jane has a parent Sally and a parent Bob. But what we're looking for are the grandparents of Jane. So that's going to be Mary, Al, Anne, and Mike. Okay, so let's see how this would get evaluated using unification and backtracking. Well, maybe I can keep that up here. First of all, this query is going to excuse me, be partially resolved by doing this. Parent, some P is a parent of Jane, and then we're going to have parent G is a parent of P. All right, so that's how it's going to get resolved. And so to figure this out, what we're going to do is we're going to look for satisfaction via unification of this first antecedent, P, Jane. So what are the parents of Jane? Well, it's Sally and Bob. So let's write this down. So this is going to resolve into parent Sally, comma, Jane. And then that is going to, maybe what I can do is just shrink this down so we can have it while we're working here. That way we can see it and do this resolution at the same time. So I'm just going to shrink this way down here to give us a little bit of space to work with. Bring that down here, and then we can do our work. Okay, so parent Sally Jane. Okay, so that takes care of that first antecedent. And now we have a G and P. So what, and this is G, oops. This is P. This is C. And so we're looking to satisfy the second part, which is the second antecedent, parent G, comma, Sally. So we have to figure out the solutions to that one. Well, who are the parents of Sally? Well, Mary and Al. So we've got parent Mary, comma, Sally. That's going to get me my goal state. And this is going to be G. And this is going to be C. And whoops, sorry. This is going to be P. All right, so we reached a goal. And P is equal to Sally, G is equal to Mary, and C is equal to Jane. All right, we have a second one as well. If we say parent Al, Sally, that also reaches our goal state. So we're at our goal, and in this case, P is equal to Sally, G is equal to Al, and C is equal to Jane. So we're going to return G of Mary and a G of Al. But we're not done yet because we have another unification here. And that is parent Bob, Jane, and that lets us resolve the second antecedent, parent G, Bob, who are Bob's parents. Well, we have one satisfaction of that, which is parent Anne, Bob. That reaches our goal state. And G, P is equal to Bob. That's the parent. G is equal to Anne. And C is equal to Jane. And then we have one final one as well, the other parent of Bob, which is parent Mike, Bob. and we reach the goal. I'll put a G here. P is equal to Bob again. G is equal to Mike. And C is equal to Jane. All right. So that allows us to return G of Ann and G of Mike. So now we have Mary, Al, Ann, and Mike. Perfect. Okay, so that gives you an example of a pretty somewhat a reasonably involved unification and backtracking, but we can do one that's even more complicated. All right, and that is Ancestor. All right, what does Ancestor look like? So we just want to know, is X an ancestor of Y? So what would the rules be for X being an ancestor of Y? And, whoops. Okay. Ancestor X, Y. X is an ancestor of Y. Well, X would be an ancestor of Y if X is a parent of Y. That's definitely an ancestor. And then one that's a little bit more complicated is X is an ancestor of Y if X is the parent of some Z, some child Z, and Z is the parent as the ancestor of Y, is some ancestor of Y. So this is interesting because this is going to trigger recursion. And the evaluation of that recursion can get rather interesting. So let's try an example. Our query is going to look like this: Ancestor A, Mary. And so our expectation is that we're going to find out who the ancestors of Mary are. Now, if we go back here a little bit, let's see if we can get to our ancestor tree here. We can see that for Mary, her ancestors are going to be Ruth, Jim, Esther, and Mick. So somehow the rules that we've set up for ancestor are going to have to locate that. Now, I have to tell you that this trace is fairly involved, and I think it's worth going through it. You can listen to my explanation, or you can sort of move the playback a little bit more quickly so you can see how the backtracking and unification work. But it's really important to understand. But the big thing that you want to understand is there isn't any magic here for how this works. There's a method to how Prolog goes about resolving these horn clauses. So here we go. Now remember, there's two different ancestor clauses. The first one simply says X is an ancestor of Y if X is a parent of Y. So the first thing we're going to do is try to see if we can resolve those, resolve that particular antecedent. And it turns out that there are two cases where we can find parents of Mary. And if we look back here to the tree again, we can see that the two parents of Mary are Ruth and Jim. Those are relations that are stored in the database. And so, resolving this, we're going to see one resolution being parent of Ruth, or parent of Mary is Ruth. That's going to be a goal state. This is A, and that is Mary. So it's a goal with A equal to Ruth. So that'll be one thing that's returned instantly. The other thing that's returned instantly is Jim. Jim is also a parent of Mary. That's a relation that's stored in the database. And so we're going to reach a goal and A will be equal to Jim. Discovering the other two ancestors turns out to be not trivial because the database and the program don't have any idea where those ancestors are located. So it's going to end up looking at all the relationships and all of the facts that are stored in the database in an organized way, and eventually it will uncover these ancestors. But it's not pretty. So let's take a look at how that would work. Now, if we had a giant whiteboard, it would be a lot easier to write this all out. I'm kind of constrained with this tablet, which is a little frustrating, but I think I can break it up into some pieces that are digestible. Okay, if the basic parent relation doesn't work, then we're going to trigger that recursive antecedent, that second horn clause, and that is parent A, comma, Z and ancestor Z, comma, Mary. Now you'll notice I'm not writing out parent and I'm not writing out ancestor because there's a lot to write here and I just don't want to take up the space by writing those out. So P stands for parent and A stands for ancestor. So the thing that's fixed here is Mary, but the thing we're going to resolve first is parent. So we're going to look for every possible parent relation, every single one that's in the system, and there's quite a few of them, and we're going to see if we can, based on that parent relation, if we can use the ancestor relation then as the second antecedent and get some truth to resolve the horn clause being true. So every single parent relation is going to get tested. And almost all of them are going to fail because what we're looking for is something that is an ancestor of Mary. And if we look up here, the only things that are going to be ancestors of Mary are Esther, Nick, Ruth, and Jim. So we'll have Ruth and Jim repeated again in our final result. But all these other parent relationships, Sally and Bob's relationship, Anne and Mike's relationship, Jean and Joe's relationship, and Mary and Al's relationship, all those relationships which we're going to test, the ancestor, recursive ancestor horn clause is going to end up returning false. But we have to look at how some of those work to just believe that it's going to work, and then we can see some horn clauses resolving to true. Okay, so let's take a look at the first one. The first parent relation is the relation between Sally and Bob. So we can assume that that's the first one that the database encounters. And so let's see if the relationship between, it's the Sally being a parent of Jane. Okay, and so let's see if Sally being a parent of Jane resolves into an ancestor relationship that allows the second antecedent to be true. All right, it turns out it's just not going to work. All right, so we'll look at, there's so many examples here, but we'll look at this first example where we have a parent of, where Sally is the parent of Jane. Now, if you think about that, right, Sally is the parent of Jane, and Mary is an ancestor of Sally, which is an ancestor of Jane. But we're looking for ancestors of Mary, not places where Mary is an ancestor of something. So this ancestor horn clause is going to end up resolving to false. But let's see how it ends up being false. Okay, so this parent Sally Jane, that is going to be true. So that's good. But the other part that we have to resolve is the ancestor part of the horn clause, the second antecedent. And so here we're going to ask, is Jane, because that's our Z, is Jane an ancestor of Mary? Now we already know just visually that Jane's not an ancestor of Mary, but let's see how the system resolves it. So the first thing it's going to do is it's going to say, well, there's two ways to resolve this ancestor horn clause. The first is a real simple one that asks the question, is there a parent relation where Jane is the parent of Mary? So how do I know it's going to do that? Well, that's X, that's Y, and if you recall the definition of ancestor, one of the definitions of ancestor is X is the parent of Y. Well, there is no relation, Jane being the parent of Mary in the system, so this is a fail. All right, well, the second way we can resolve the ancestor horn clause is by asking the question, is the parent of Jane Z, and is the ancestor of Z Mary? So this is my X and this is my Y, all right? So that's rather interesting. So first of all, can we find any relation where Jane is the parent of some other person? Well, we could scan the database, but if you take a look at this, Jane is the youngest person in the entire tree, with the exception possibly of John. And so Jane is not the parent of anything in this system. And so that means that this is going to automatically fail because this parent relation can't be found. We can't find a relation where Jane is the parent of anyone. So that's going to fail as well. Okay, wow, that was a lot of work just to handle one of the unifications for parent, one of the relations that we found. But we have to do this for every single relation, parent relation that exists in the database. That's a ton of work. So what I wanted to do is just move along and explore another parent relation because it's a little different from some of the other ones. So the one I wanted to look at is the parent relation between Joe and Al. Okay, so take a look. So, Joe is the parent of Al. So we just want to explore that and see if there's some way that this relationship, parent of Joe, Joe being a parent of Al, somehow that could be used to discover if we've got an ancestor relationship with Mary. Now, clearly, visually, that's not true. But let's see how the system resolves it. Okay. So another possible unification is the parent of Joe, Al. That is a fact that's true in the system. And then the question we're going to ask is, well, if that's true, then is Al an ancestor of Mary? That's the question. So this is my X and this is my Y. So I'm running out of space here. Like I said, I wish I had a whiteboard, but I don't. So, oh, but I do want to just show this. So this is yet another possible unification of that horn clause above. All right, so I'm going to just move this to its own area. Copy, and we'll just paste it right here. Give us lots of room to work with here. All right. So, well, let's see. There's two ways that this could get resolved. The first way is really simple, and that is, do we have a situation where Al is the parent of Mary? Because that's the first tail of the first horn clause that describes Ancestor. Well, we don't. So this is a fail. Al is not the parent of Mary. Okay, well, then let's see what happens next. Do we have a situation where Al is the parent of some Z, and then that Z is an ancestor of Mary? All right, do we see that? Well, let's see. Well, Al is the parent of Sally. All right, so we can write that down. That's this part, we can find something that works where this is true. So that would be this situation. Al is the parent of Sally. All right, so that means that Sally is Z. Now, can we satisfy an ancestor relationship where Sally is the ancestor of Mary? All right, well, let's see. We're going about this recursively again, right? This is true. Al is the parent of Sally. That is definitely true. So we have to resolve this ancestor horn clause again. And again, we go back to basics. The first way we're going to try to do this is real simple. And we've got a situation. Do we have a situation where this is our X and this is our Y? So is Sally the parent of Mary? So the answer to that is no. Mary's actually the parent of Sally, but Sally is not the parent of Mary. So that's false. So this is a fail. All right, so now we're going to try a recursive investigation. And the recursive investigation is going to be, is there a parent is Sally the parent of some Z, and then that Z is an ancestor of Mary? Oh man, this just keeps going on and on and on. Well, let's see. In order to resolve this, we go back to the same thing. Let's see if we can find a match between Sally and Z. Well, it turns out in this case, Sally is the parent of two different children. So we're going to resolve the first one. We're going to say parent Sally and Jane. And there's a second parent, which is parent of Sally and John. Okay, so this is my Z. Jane is my Z. And so what we're looking for here is that's true, but in order for this ancestor clause to resolve, what we're going to look for is, let's see, let me go back here. So we're doing parent Sally Z and ancestor Z Mary. So we find a parent of Sally, which is Jane. And so what we're trying to do then with that unification is say, okay, is there an ancestor of Jane for Mary? In other words, is Jane an ancestor of Mary? So we got to figure this out. So in order to resolve the Jane being an ancestor of Mary, we're going to look at two possible horn clauses. The first one is there a parent where Jane is the parent of Mary? And the answer to that is no, there is not. So this is a fail. And then can we find then a recursive solution with parent and ancestor? So do we have a parent of Jane, some Z, and an ancestor of Z and Mary? So we can't continue any further down this line, and that's because there is no relation where Jane is a parent. So this fails. So the exploration of the solution down this branch is over. And furthermore, we have something very similar that works with Sally and John. In fact, everything that's over here is going to be repeated for Sally and John instead of Sally and Jane. You can just, everywhere Jane appears, you can just put John. You're going to have the same behavior. So we're going to get fails down the line here as well. All right, well, so what that means is our attempt at unifying all the way back up here, our attempt at unifying Joe, our attempt at finding out whether Al was an ancestor of Mary has failed, basically. Okay, so what's left? Well, there is a track that does get us to a goal, and so I want to just pick one of them. Otherwise, we'll be here forever doing all of these. So let's take a look at one where we get to. I'm just going to do ... and I'm going to put a little arrow here because I've got a little bit of space to write here. But what would happen if we had parent of Esther, Ruth? Okay, that's a valid, that's valid, and so that's true. And then ancestor of Ruth, Mary. Okay, so the question is, does this resolve to something true? And it turns out that it does, because the first horn clause that we go to resolve is the simpler one for ancestor, which is, this is my X, this is my Y. Is Ruth the parent of Mary? And the answer to that is true. So we've reached our goal. And here, our ancestor is going to be equal to Ruth. Okay, that's kind of cool. So let's see, anything else that we could do here? I think that's pretty good. So that's a pretty good example of how you can do backtracking and unification to explore recursively a horn clause that uses itself as part of an antecedent.